Hi everyone, my name is Jove, and this is David, my friend, and we are in the Pulsar Summit in SF 2023. And David and I work in the same team in Splunk before, and I guess maybe David, you can just give an intro to the audience. Yeah.
Sure, my name's David Karamgard. I'm a committer on the Apache Pulsar project and also author of Pulsar in Action, where I've been giving away signed copies today at the Pulsar Summit right after my talk. I did a one-arm demo, live demo, and everything went well, so everything's great. Thanks, Joe, for having me. I really appreciate it.
Yeah, I mean, we being in the same team, we used to have meeting almost every day.
We did.
We do code review to each other, and it was a really cool memory. But you spend a lot of time on Pulsar side, writing the book, doing dev advocate, and writing a lot of demo or some other maybe requirement or code review stuff. Can you share a little bit about like for people who for say one group of people who are new to data streaming, what is Pulsar, why this is invented, what's the difference between Pulsar with other technology, and how get started, and maybe we can touch on other topic about the advanced use of Pulsar maybe. Yeah.
Oh, sure, yeah, thank you. So I've been working with Pulsar for over 6 years now. Got started in 2017. I was working on Kafka before, so I was working for Hortonworks and Professional Services, and we had a Kafka offering. It was probably 0.8 or 0.9 version, so very, very immature, and people just hated it. It was miserable. It was very hard to work with. People, really, pick the number of partitions you have, and no matter what number you pick was always wrong because you had to rebalance things right away. And then Pulsar came along on my purview, and so Pulsar was the enterprise messaging and streaming system that was developed at Yahoo to solve a very specific problem, but then they evolved it to be a better system. So the problem they had at Yahoo in 2012 was that they needed geo-replication. They have data coming in from all these different stock ticker quotes, and they needed to get it geo-replicated to 8 different centers where you can go look at Yahoo Finance and get basically essentially the same data. Nothing in the world did that today, including Kafka, which came out of LinkedIn.
So at that time,
didn't do it.
When you guys in Yahoo kind of invent Pulsar, I'm not sure whether that's the original name, but anyway, at that time, Kafka is there already.
Kafka's already there.
And you are not really happy with that kind of limitation or the issue for Kafka. You have to create something new, right, for that purpose.
Yeah, we have the advantage of being a late adopter. We looked at what, a lot of people are good counterpunchers. We looked at what they did and what they did wrong and said, let's do this differently. And one of the key architectural decisions for all messaging systems it's not fair just to pick on Kafka. All messaging systems up until Pulsar were, they decided to co-locate the storage and serving of the data with where it's stored. So your brokers have the data in place. It can only serve data for a subset of topics. Pulsar changed it up, so let's have a completely separate stateless layer for brokers and then have a separate layer for storage, and you can dynamically swap the number of topic assignments, allows you to rebalance topic assignment without moving data, without topic repartition.
Bookkeeper, right?
That's the Apache Bookkeeper, a storage layer, which came out of
they're also coming from Yahoo, I think, right?
Came out of LinkedIn from our CEO, CJ.
Okay,
I was the PMC chair that he invented that. It was designed to be a system to help Hadoop as well. Okay, so it came out of that era. Yeah.
So so I guess one of the key difference between Pulsar and Kafka is that you guys have this layered storage from the day one almost, right?
Yep. So we decided, and that's where we lean into the cloud native story, right? So the brokers are stateless, so they can scale up automatically and down dynamically without data movement. So you can look at naturally containerize those and put them in things like Kubernetes to say stateful sets and replicas. Hey, I want to scale up another one. You can just scale up another one, and I don't have to rehydrate them like other messaging systems, RabbitMQ, IBM MQ, Kafka. Okay, you put up a broker, if there's no data in it, it can't really serve data. Now you can publish data to it, but it can't serve data. So when you're trying to solve a scalability problem, I have too many consumers consuming from this topic, adding new brokers in those types of messaging systems where have co-located storage and compute doesn't solve your problem. Okay. You haven't solved it, so by adding a separate layer, you now have that scalability and dynamic ability to do that.
Cool. But I mean, those are really, I see the point that it hits a certain limit of Kafka. You guys create something new, but is that add extra complexity into the system, or like this is mainly for advanced use? I mean, is that for the new user who have no idea about Kafka or Pulsar?
Yep.
What's their first impression for the maybe first 10 minutes, 20 minutes? Do they have to learn a lot of new concepts?
They do not. So we have this. We support a very simple pub sub mechanism. Our API from client is send a message, consume a message. So from an end user perspective, it's very, very simple. And we support multiple protocols. So if you are familiar with something like a Kafka client or RabbitMQ client, and you have existing code that does that, you can use Pulsar as your backend seamlessly. So the APIs just map identically, and we're a pub sub messaging system. So our concepts have been around since the 1990s. Again, send a message, publish a message, consume them, seek to a certain message, consume from this point. Very, very straightforward. Not a lot of semantics, but very simple primitives to do a lot of string processing on top of it. So it's very, very easy to use. Not a lot of work involved.
Yeah. Say, the title of this episode is, or the podcast is Streaming Caffeine, right? It's more about the general streaming stuff. Not really have to be certain open source project or vendor. Yep. I do get this more like aha moment. Like even today, like someone mentioned that is, hey, they use fairly large deployment for Pulsar, and someone asked why Pulsar not Kafka, and that person answered that because they also have lots of queue-based consuming model, right? I guess that's Discord, right? So they have a lot of workload. It just need a queue. They don't want to manage so many partition, and they need something as a queue, something as a pub sub, and the Pulsar nicely support both of them. Maybe you guys support even more, right? But it's a really good solution for them. Have a kind of one-stop solution to solve all different consuming model, right?
Yep, that's correct. When we had the late adopter, edition, Kafka was great in that it invented the concept of event streaming, right? It's like write the data once, read it many times, process it in natural order, but there were certain assumptions around how that data is stored and processed, and that sort of thing. And so we said, well, why make it an either or proposition? You can have pub sub instead, right? So make a natural interface to do traditional queuing, work queues, that types of things. Fan out consumers was built in from day one. It wasn't an afterthought. That Kafka is still, quite frankly, working to get caught up on. They're going to add messaging eventually. We've had it from day one for about a decade now. So
I see this. Healthy competition in this open source world. That is, say, last month I was in Current, right, and they mentioned, there's a new feature in Kafka which is having the queue API. I guess Pulsar supported a long time ago. So I guess it is really a witness of the kind of developer feedback, right? They do need a different consuming model, and they don't want to manage two different stacks.
Yep, the community is growing, the streaming adoption is growing. Kafka used to be the default, de facto standard, but the fact that the community was asking for these features for years indicates that there were gaps. It was not a complete solution. They're getting the feedback, and it's great that they're responding to these things. But and sometimes when they would come to the booth, I was a current too. I say, well, that's great. We've had it for 10 years. That's great. They have pubs. Tiered storage. We also have that. Sorts of things that they've needed for years. Multi-protocol support. Well, they don't have that, right? We have these sorts of things. And so we try to make a holistic solution and respond to the market. So our goal is to have a single streaming platform for all your protocols, all your messaging semantics. Again, now you can offload the stuff into a Delta Lakes and all these, directly into tiered storage offload. For your tiered storage can now be stored directly as a Delta Lake. So it becomes a single unified platform for everything. You just have one thing, and then you send messages to it, and that's it. There's no, I have Rabbit for this, I have Kinesis for that, I have Kafka for this, I've got some JMS over here. It's all a single system, single solution.
Okay, cool. And you just finished your book signing. So maybe tell me about the book. Right? I mean, it's not really a thin book. It's quite thick, and you must put a lot of effort. And I guess we also chat a little bit that it's really a challenge to write a book in a kind of a definitive way, but the technology itself is still evolving almost every week, every month.
Yep, that is its own challenge for writing a technical book. That just when you think you're done, it's almost obsolete the day you publish it.
Okay.
But it's about a 400-page book from end to end. Took me 18 months to write, spending most of my weekends, 20 plus hours a day doing things. I wanted it to be a very good, complete publication on Apache Pulsar. The market didn't really have anything on that. I said, I have this knowledge. I want to share it with the world. I think this is a good format for some people. It's a natural thing. It works through it's from Manning Press, and so it works through a fictional business model, building out a certain application, a food delivery system based entirely on streaming data, so you can do things like time prediction, order inventory, taking these things, inventory management, all through a streaming approach to these things to say, not only, so it's a bit technology specific, but in a way it's how would you solve this problem using streaming, which is natively a streaming process, and solving problems that are streaming problems natively. And Pulsar just lends itself naturally to that, but you could do similar things with other technologies as well.
Yeah, cool.
So.
And we are not sure how long this book will remain free to download for XYZ months or weeks, but I guess people who really want to get started with Pulsar, I guess having that book will be very easy compared to like reading the doc. Again, docs will be more up to date, but having a book telling some story, telling some concept, can give you a very solid foundation to learn this step by step, right?
Yep. No, absolutely. We still have some of our support engineers who work on Pulsar every day say, I keep your book on my desk and I read that first and then the documents second. So it's high praise for these people who are very, very intelligent and very, very smart to still go back and look at that thing. I wanted to that was my goal, was to make it the definitive resource for it and people to be a foundational piece to grow the community. This is Pulsar. This is why you should be excited about it. And it's not just a theoretical thing. You can do real things with it. And so hopefully that served that purpose. And it's people keep asking me when there's going to be a second edition, including you. And I keep saying, well, maybe, because it is a lot of work, but it is also very rewarding to see people that say, I read your book and now I do something really cool.
Yeah, and once they have this solid foundation, for example, what is say persistent topic or partition topic, once they have the foundation in the good way, I mean, they will be much easier to understand new features, right?
Yep. Once they understand the basis and the core problem that we're having, and then because you throw out a solution and you assume everybody has it, has these sorts of things, they don't understand it, right? So like the recent thing I did, again at Current, I did a talk we did on Oxia, which is our metadata storage thing, and that's new because everybody who comes from a Kafka world says, well, ZooKeeper's bad, and so they replaced it in their own way, and I have my own opinion on whether that was the right approach or not, and that's the thing, when you try to explain that, well, what's the problem is they're solving is that you have to keep metadata. Again, having the separate compute storage layer means you have to have somewhere to keep the linking of the data back together. Where my topic sits in the storage system, that has to be stored somewhere in a distributed, reliable system. And ZooKeeper is great for consensus and getting, leader election and maintaining topic ownership and things like that, but it's not meant to be a distributed database. And so a lot of systems, including Pulsar ourselves, Kafka sort of abused it for what it was not intended to be. I'm going to shove a lot of data in here and persist it, and it invariably becomes problematic, it slows down. And so we solve that with a very different way. So now we present the solution to say, look, and so, well, that's all theoretical, right, Dave? That's just whatever, but what's the practical impact is, it would limit like the number of topics you can have in a system. So with systems like Kafka or RabbitMQ, you're limited to 500,000, maybe 1 million, something like that, total number of topics. With Oxia, you can do 10 million topics today. And the way it's scalable, we can do 100 million probably by next quarter, 2 quarters out. And so, okay, well, what does that really mean? It changes the way that you attack problems, right? You don't have to always have a partition topic and spread data out. You can have a topic per consumer. You can have 5 million topics to logically structure your data and don't have to do sorting and partitioning to say which keys are where and what the sort of thing. You can just logically structure the problem as you want it to in a streaming manner, and now you're no longer limited. So it's a whole new pattern for designing and structuring topic data that didn't exist a year ago.
Wow. So I forgot what's the number for the number for partition in the, even largest or the normal deployment, you see like 100 or 100K, 100 million partitions?
So currently, like the largest number of topics we had would be maybe if we tweaked ZooKeeper just right, we might get 2 million topics, 2.5 million topics. And that's very hard to do, and that took a lot of specialized tuning of ZooKeeper, and it goes back to, the way it is. It's designed to keep data in memory only, so it's very efficient. As soon as but periodically you have to take that data and snapshot it to disk. So the more data you put in, the longer you have these pauses when you're writing all that data to disk, and then in a distributed high volume system, that causes problems, big interruptions in your system. Now that we've separated that out with our Oxia solution, we have it's entirely Kubernetes related, and we let etcd do the coordination, so it just does the leader election, and we have a separate data nodes that can store the metadata, entirely separate, and those are partitioned and everything internally. So you're no longer limited. Writing data doesn't become a critical blocking feature anymore.
Okay.
And so if you have 100 million topics, that's fine. You can just keep writing the data and everything just works. So it's, in theory, it's like a database. You don't think about how many tables can I have in an Oracle database. You can have as many as you want. They're cheap. That's how topics should be, because that's the new database is going to be your streaming data structure. That's really what it is.
So OZ is not really a replacement for etcd, right? But can be a replacement for ZooKeeper.
It is a replacement for the ZooKeeper metadata store, and it uses etcd for the coordination, and it uses a separate. So we separate it, right? ZooKeeper solves consensus. It's good for locks and distributed locks and things like that. It is not great for storing data. But metadata store requires both. So we went back to the first principles and said, why try and use a tool to do two things when it's not designed for that? Pick the right tool for the job. Okay. So etcd is going to do the coordination, and we'll have a whole separate system for storing data entirely independent of that. Okay. And so now each one's most efficient, highly scalable, resilient, redundancy, all these different things, and now we have an ultimately better solution for those things. So we build it for the next step. So as streaming and messaging systems become more popular, as you start, because we're a natively multi-tenant system, you're going to have lots of organizations, lots of topics. You don't want any sort of artificial constraints on the system because of architectural flaws in the underlying platform. Okay.
So all these incubate and contribute by StreamNative, right? And Pulsar is the first system. Is the other system going to use this as a metadata store, or you guys going to promote more and encourage more people to use? We
think ZooKeeper replacements is still something that's an ongoing effort. We've seen other people do a C++ replacement recently. I think ClickHouse.
ClickKeeper, something like that.
ClickKeeper, they call it ClickKeeper. There's still a need for it. ZooKeeper is great for what it was, but when it starts getting misused, there's a gap. So our hope is it gets adopted and widely used. We have no problem.
Is that only for Java community, or it can be language neutral?
Our implementation is in Java, but it's going to be language neutral. It's just an API.
Yeah,
You expose an endpoint to it, and you can use it and deploy it. We want it. It's Apache license, 100% open source. We hope people come around to use it. That's why I'm giving talks on it to say, hey, we're not, we built the right solution, and we think more people could use it. It'll benefit from more people using it. I think that's our nature, right? We release things in open source. We get feedback. We ultimately end up with a better product. Cool. That's our philosophy. So.
Wow, and also join the talk you today have to have the table view of the Pulsar topic, right? And I get the impression that is, you guys enacting more and more features. Two sides. One is, besides this one, what other kind of very interesting feature you want to share with the audience for the recent release of Pulsar, maybe for the recent maybe half year? And then maybe we can also talk about the streaming CQ in the next topic. Yeah.
Okay, sure. So TableView is a very interesting one. We added about 210. It's our answer to like the K-table sort of solution. So I can have a logical view of a database view of a topic rather than having to have a stream and have it in memory processing. So that definitely is one of those advantages. We added transactions recently, full support. And like I was talking a little bit earlier, we have tiered storage offloading. So our CEO just gave a talk on it about how we evolved. We came out with it in 2018. Other people have since come along and implemented it. But we really think rather than storing it in a native Pulsar only consumable format, we said if we offload these things, let's convert it to a Parquet file, which is native to your these Delta Lakes sort of things. Your Hootie, your IceBerge, all those sorts of things. And natively store it there and include the schema with it. It used to be just a black box. It's just, there's some raw bytes in here. Yep. You go through the broker to read it, and then that's how you attach that schema to it. Now we store it with that schema. So now you can query it in real time, and all these systems can access it directly. So our tiered storage adds additional metadata to it that I think that was missing for years and allows your streaming platform to actually become a database of record as well, because it's queryable data after the fact. And people have been asking for that for years. You're going to leave with these other streaming messaging systems. They're very like Flink SQL and the Rising Wave and these new ones. They're designed to consume the most recent data and process it efficiently. But if you're doing longer term query, most of your data is in longer term storage, offloaded to more efficient storage. And there's no way to query that if you don't have a schema associated with it, right? So by doing that, now opens up 90% of your streaming storage to common systems that already exist and know how to read these formats.
So if someone configure this right and say, I only want to keep the recent 7 days in my a broker or bookkeeper, and other than that, they move to S3, then can they still query those old data like half a year ago through the Pulsar API, and you guys will fetch or read data from the data lake?
Yep,
Okay,
that's
cool,
that's
yeah.
exactly what we do. Because it's a two-tiered system, when we go to look at where the topic data is, we expect as part of that metadata a pointer, a URL, whether it's a bookkeeper, local disk, quote unquote, or if it's an S3 bucket. So we naturally know we're going to make a network hop to go get that data. So it's seamless to you, as there's no data movement in. Again, that's the bane of most messaging systems' existence. That's like the repartitioning problem. If I can only serve data from where the broker is, then the first step to serving that data from tiered storage offload is what? Bring it back onto a broker somewhere.
Okay.
And that's an expensive operation that most people just sort of, well, yeah, they assume it's an assumed cost. Well, the way we do it is you just read that pointer and you go directly. There's no rehydration. There's no data movement. You just natively go access it and read just that data that you need. So it's
how
much more
the API
efficient.
look like? Is that, I guess it's more than like I want to offset of earliest. You might want to specify what's the timestamp you want to retrieve data, right? Or
You can, yeah, so by embedding the schema now, that allows the query engine to say, select from this data where the field is equal to this, that, and the other, and it can scan the records, feed the records to that query engine, who can then parse them out and drop those records and bring back only the ones that it's interested in.
So help me understand better. So you mentioned the select star, the CQ, but Pulsar don't natively support that? I mean, maybe you guys have this new CQ for.
No, we don't have SQL. We use that Parquet format, which is developed in the Hadoop space back in the day by Cloudera, and it's an efficient indexing system so that there's systems that today know how to read that. So we just allow them to plug directly into our tiered storage offloaded and use the same query engines that you know and love, but instead of reading it from their systems or what other systems you offloaded to, you can also read from your streaming as another data set.
Okay.
So they just, you point it to it, they say, oh, this is Parquet, I know Parquet, and then they just do the rest automatically, so.
Yeah, nice. Yeah, so let's talk more about the SQL side. So my understanding that is, last Polar Summit I joined a talk, I guess it's Neng or someone, he mentioned you guys are working on a feature to using SQL to do some maybe transformations or routing, right?
Yep.
Then that's also a very nice integration with Flink, right? So you can also use Flink to process data, and streaming database such as Time Plus Proton or Rising Wave or other system can also consume data from Pulsar. Is that going to be a mixed solution, or yes, will be more enhancement for the building SQL features from Pulsar? Right?
Yeah, that's a great. So those are really separate solutions in SQL. So you start with SQL because everybody knows SQL. It's the prime. Everybody knows that language. For the one that you're referring to about we're calling it PF SQL, Pulsar function-based SQL, and that's designed to do content-based routing on the broker side, right? So let's say you're a consumer. I want messages from this topic, but I only want messages where the fields are equal to this, that, or X, Y, or Z. You can basically write a SQL statement to route data from the global topic into a secondary topic on the broker side, so you don't send 90% of the data that the consumer is not interested in and have them drop it, but pre-filter it, and then it's in a secondary topic that you can just read directly from and save that transmission cost, save all that network bandwidth and all those different efficiencies by just doing that. So you start it up, you run it, and it continuously runs and filters it, and then your consumers can pick and choose what data they want from that. So that's designed to solve an efficiency problem, bucketing problem sort of thing. Other messaging systems like Solace use hierarchies to do similar things like that. I'm going to nest these things up. You can implement all of that with regexes on and filtering on those type of patterns. So filter data into these subtopics and then grab me 5 of those, and then that's your entire hierarchy of data structures that matches. So we solve that problem that way. Now the Flink integration and other integrations with like Time Plus and other is still, we lean in, so we try to expose our metadata to you in such a way that you can your query engines can be optimized and know exactly how to prune the search space, find those segments of pieces of data that they're looking to query, and process it inside your distributed systems and present it back to your customer. So again, like Flink can natively read it, Time Plus can natively read our information, and our goal is to make that as seamless as possible so that it's transparent to the user where they're actually reading it from while they use their distributed engine of choice. So.
Okay, cool. And
Yeah.
maybe the last few questions. That is, what are the coming exciting features in your mind for the Pulsar project?
Yeah, there's a lot of things on the roadmap. So again, we spent a lot of time, this effort on getting our protocol adapters up to speed.
Mm-hmm.
So that's a big feature that we've decided to make it, write it in with a single system, consume with MQTT protocol, AMQP protocol, and just a lot of people have Kafka out there. They have Kafka applications, and they're not going to give it up anytime soon. We've been really working hard on making sure that every API in Kafka is supported 100%.
Mm-hmm.
K-tables, K-streams. We're integrating the schema registries between the two. So if you have an existing Kafka schema registry, or you publish using Kafka to Pulsar, we copy that schema over to Pulsar, so everybody knows exactly what you're talking. These sorts of things. Mm-hmm. Performance improvements are a big thing. We've really had dramatic performance improvements as well. Mm-hmm. And we're continuing to work on that, and then building on Oxia are the immediate roadmap things, but there's so many things going on. Cool. Those are like the top 3 I could think of off the top of my head.
Oh, nice. Yeah, again, it's a very nice technology, right? And also it's very dynamic. I mean, the how people use that, the expectation also change, right? So,
yep.
And in the same time, I guess modern people have this natural kind of expectation to do more data streaming, right? And they might have no idea how to get started, right? So having a very feature-rich platform, but also very good documentations or the like talks, books you have really can help people to easily get started. Yeah.
Yep.
And that's also kind of the reason why we work on the company, say 10+. That is, we really want to lower the barrier of that people can process data in Kafka, in Pulsar, in their first 10 minutes, right? So otherwise, it is really possible you can spend some time to spin off your Kubernetes cluster, say have a Flink, put some jar file, and check a doc, and get something out maybe end of the day. But if you can get this out like for the first 5-10 minutes, that'll be great. People will be very encouraged to do more. Right? It's not really a big effort. You don't really have to hire a lot of folks. So the usability side really can be improved, and also people, hopefully that more people will be more okay to have a cloud version, right? That's also the hope for like StreamNative cloud, 10+ cloud. Yep. So people don't have to, once they recognize and appreciate that technology, they want the expert to operate that.
Yep, that's exactly right. They have business problems to solve. They don't want to have to become infrastructure experts and specific technology experts in order to solve business problems. They have to say, this is a good technology to invest in. This is the way we're going to slice up problems. We want to do event-driven architecture. We want to do time series analysis. We want to do windowing analysis. Give me an endpoint and allow me to start building my process on top of that. Don't bore me with all these details. Make it easy to work. Let me make it reliable. Make it resilient. Make it easy to use, and they will come.
Yeah, and even you don't have to talk to the cloud sales folks at the day one. They can just try the open source version. Right? Both of us are open source at Apache too, so people can try either compile it by themselves, check the source code, or try the Docker image.
Yep. So Docker image, standalone, run it yourself. We have Kubernetes and run on Minikube if you want to do it. If you want to play it in your home lab, we have some open source operators. So designed to be as frictionless as possible. We're continuing to refine that process, but or go to StreamNative Cloud. We just have a public endpoint, spin it up for free and start.
Yeah, and this can be really a takeaway for people who watch this episode. That is, there's a lot of new technology. You might hear new vendor, new project almost every month, every week. But that's for a good reason, right? Because it's a dynamic world. People really want to see where my Uber car is, where my DoorDash order is. You don't want to miss anything, right? And the consumer side, people really have this kind of new pattern or expectation, and on the business side, similarly, CIO don't want to wait for one day to get a report, right? So everyone wants something faster. And feel free to check out like Pulsar, 10+, maybe other technology. It's not so difficult to use, and enjoy your first 10 minutes, 20 minutes to get hands dirty, see something results. Then you can move to next step, right? And the first step is always very important. So we don't want you to check a lot of documents to get started. You can literally just start from a Docker image or check some README to get your hands dirty. And welcome to this new data streaming world.
Thanks.
All right, cool. And I'm so glad to talk to you again. And I'm sure we'll join the next Pulsar Summit, and we'll see each other in another conference.
Oh yeah, it was good to catch up with you as always. It's good to
Yeah.
see.
I'm not going to shake this hand. I will shake.
Don't shake.
this
Yeah, shake the left hands. This one's hurt.
All right, thanks so much.
All right, thank you.
And
Bye.
see you in the next episode. Thanks so much. Bye.
Bye.